Modeling of an electrical system. Here's an example of how an electrical system can be modeled. From the Project Navigator toolbox, you can access the plant systems list to add the new type of system. Choosing the electrical system type, a color and a name is assigned to the new system. From the drawing menu, you can access the electrical systems section, which includes all parametric objects and connection entities that belong to the electrical category. The electric meter object is added as a first entity. To do this, select the first element of the equipment and devices row by system type. Using the parametric configurator, you can choose the electric meters category and the single-phase electric meter type with a nominal power of 3.0 kilowatts. From the Accessories and Switchboards row, select the switchboard object and access the parametric configurator to assign its properties. The only category available is switchboard, while the flush-mounted switchboard is chosen from the types proposed. In the next step, the model with the number of modules equal to 12 times 1 is selected and the configuration is concluded to insert it into the project. By default, a blank cover object is arranged in correspondence with each module, which can be replaced with a different element by accessing the BIM objects library. For example, for the first module, a 4-module magnetothermal switch is chosen. The same operation is repeated on the next module, this time choosing a differential magnetothermic circuit breaker switch with 4 modules. Again, the same choice is also applied to the next module, covering all available modules. Now we can move on to the device box entities. The device boxes and power turrets are available, each with specific types. Let's select a recessed socket box with 3 modules across one row. We can finish off its definition with a cover plate by selecting one with a different profile directly from the library. By default, in accordance with the choices made, the box consists of 3 modules, each identified by a cover object. The central module is replaced with an on-off button. Another 3x1 module recessed device box is also added, this time positioning it at a delta of 40 centimeters. Now let's select a module and access the library, choosing this twin 16A, 10A socket. For the telephone line, a flush-mounted device box is positioned at the same height of 40 centimeters and therefore a telephone socket is added. If enabling the fruit box entity again, from the wizard for the guided creation of the object you can choose the turret's category and the type double-sided mini-column with 4 modules per side. The object is positioned and the modules are customized for both faces of the turret. In this way, all the necessary socket points and switches are added to the model. Then we want to position the light point objects. The functionality of the magnetic grid can be exploited to arrange multiple entities of the same type at regular distances with immediate modes. From the Electrical Systems section of the Drawing menu, select the first element, Electrical, of the Equipment and Devices row by type of system. Using the wizard window you can choose a square ceiling light point object with absorbed power 34 watt. In the Action section of the upper toolbar the magnetic grid option is available. Select it and, with the magic wand that appears on the screen, highlight the entire added grid. In this way, the configured light point object will be inserted at each of the intersection points between rows and columns of the grid, then 12 entities arranged on 6 rows and 2 columns. Then, for example, a circular suspended light point object with absorbed power of 17 watt is added. By repeating similar operations, in 3D or on the levels, all the necessary light point objects are appropriately configured and arranged. Continue by adding the various junction box entities to the project. From the Drawing menu, select the junction box object from the Accessories and Switchboards row. By accessing the parametric configurator, a flush-mounted junction box is selected and positioned on the wall at a height of 2.5 meters. Here you can also see a round recessed junction box is added for connecting the telephone system. Returning to the parametric configurator, you can choose the junction box's category and the junction box type with a pressurized cover. The object is positioned at a height of 2.8 meters. All junction boxes necessary for modeling the entire electrical system are arranged. In the context of an electrical system, the entities used for connection can be summarized as pipes, corrugated pipes, cable trays, etc. From the Drawing menu, in the Electrical Installation section, select the pipe, electrical entity. The Properties toolbox is specific for the chosen entity and, by modifying the relating fields, you can also modify model, size, fittings, and connectors, as well as assign it to the electrical system. The electrical connections are traced as already seen for the mechanical connections. Any surfaces that ready for a connection are colored green. When an area turns yellow, you can click to start tracing a pipeline from that point. This enables the directional cube and the protractor to choose plane and direction along which to trace the connection, followed by the 3D ruler to fix its length. Starting from a first section, you can continue to trace with a second section of electrical piping in a different direction. Provided that the Smart MEP mode is active, the curved type fitting is automatically inserted to connect the two segments correctly. With a 16 mm diameter pipe, two connection sections are traced up to the flush-mounted junction box located near the switchboard, so as to branch off two separate lines. From both built-in boxes, a connection is made with the respective visible boxes placed above them. Always using the electrical piping, the sockets and switches for each room are connected. From the drawing menu, you can then select the duct connection entity to make the connections between the exposed junction box and the lighting device points. From the Properties toolbox, simply choose the element with dimensions 40 by 10. With a mouse button click, you can start to trace the duct using the directional cube as a tracing aid, together with the protractor and ruler. The connection is then traced between the visible junction boxes and then with the light point entities. If necessary, also for the electrical connections, you can use the intelligent functions available in the upper toolbar, such as the break, replicate path, and connect options. Thanks to the Smart MEP mode, the necessary fittings are automatically inserted during definition of the entire connection path. To connect the mini column arranged at floor level, we'll choose a corrugated pipe type entity. And start tracing from the device box, move towards the base, and when the surface turns yellow, click to set the first end of the corrugated pipe. Taking advantage of the linear blue snaps, the connection is extended up to the floor level and the tracing of the corrugated pipe is finished at the base of the mini column. After fixing it, it is also possible to modify its profile using the specific functions. It is also possible to use a corrugated type entity to connect, for example, to the electrical connection of an appliance, such as a heat recovery unit, inserted in the context of modeling a ventilation system. You can of course also view the other systems that may be used in the project at any time. in order to check for any conflicts between the various entities and intervene to resolve them. For example, in this case, a section of the duct network interferes with a circular diffuser previously arranged within the ventilation system. This section of electrical connection is then appropriately remodeled. Now that we have positioned all the necessary components and defined the ducting, we can see that a basic electrical system design has been achieved. Each object added during the modeling phase of the system is also automatically added in the project library, and the entire electrical system is integrated into the architectural context together with any other types of MEP systems that may be planned for project.